a small emerging market within the broader framework that includes just plug-and-play solar home system kits that are sold as a complete kit, and that's what we're focused on at this point. I think at this point I want to pass things over briefly to our colleague and friend Hans-Peter Berghofer from the Global Off-Grid Lighting Association. And so Hans-Peter, if you would like to say a few words, I think that would make sense at this point.
Okay, thank you, Arnie. Can you hear me?
Yes, we can.
Okay, sounds good. Hello, everybody. This is Hans-Peter Birkhofer. I'm working as a technical director of GOGLA, the Global Off-Grid Lighting Association. Most of our members are manufacturing and distributing the Pico solar lantern, and quite a few also in the solar home systems, smaller ones as well as bigger ones. And we ask Lighting Global for setting up this webinar in addition to the stakeholder page, which is on the website, and answering a lot of the questions and giving the feedback. And thank you, Arnie, and your team to have this webinar now and to explain some more detailed the things which we want to do. I would like at that point also to motivate everybody of you who is in this field or planning to be in this field of smaller solar home systems to bring in your comments, proposals, and or even concerns. Since only if the whole industry, the industry community supports that structure of a quality process, it can be successful on a long run. So please, I would like to motivate you, bring in your questions, your answers, and I'm sure that everybody who is working in this team, Arnie, or also on our side, we're willing to take this serious into account to have something which is practical, which is pragmatic, but which also has a good opportunity to be a long-term quality assurance thing. Let me just make here just two remarks, and I do not want to make it too long because Arne has done something already. Some rationale, why should we expand in this area? First of all, the solar models, the LEDs, and the battery prices have been dropping due to the higher volumes. The appliances efficiency is improving. That's very important. Look at TV display screens, TV screens, or even refrigerators. They are down at wattage consumption, which nobody would have thought a couple of years ago. So it makes it possible to include these things into smaller solar home systems. And so the demand of these solar products, and it's not only lighting anymore, there are also other appliances, is growing. And these are systems which are there going to be much more affordable and available. Well, on the next page, you will see once more manufacturers and other industry stakeholders have requested to look into the neighborhood of the existing Pico Solar area, also Lighting Africa and Lighting Asia and the U.S. Department of Energy are interested to support the development of a commercial market for an affordable solar home system kits. And there is no question there are existing standards, but that mostly cover solar home systems components and not really the system level. And another thing is also the component quality assurance and the standards and the tests and the certificates are rather complex and are rather costly. So if you put the different component costs together in one system, it is way higher than what we are looking into low-cost, affordable quality assurance tests. And these are somehow the rationales there. So it means to fill a gap next to the Pico Solar and the larger solar home systems. No question, the larger solar home systems, they must be based on component specification and component certification. I think from my point of view, there's no doubt about that. But there seems to be just in the neighborhood after the 10, 15 watt of the Pico Solar, there is an area which there is a gap which is not addressed properly by the existing standards. And that is where we have to talk about. If the limit of the wattage is then 100 watt, I'm rather a little bit lower than that, because the 100 watt is already a regular solar home system which is designed and planned and professionally installed. So this is not, I would say, addressed by this plug-and-play kits. So from my point of view, probably the 100 watt is rather a bit too high. I would see it a little bit lower. But okay, that's up to us in the industry to define if we want it and where is the limit and the other requirements. So thank you very much so far, and please come in with your comments and your questions and even your concerns. Thank you.
Thank you, Hans-Peter. I'll continue on now with just a brief overview of our planned approach, and then we'll pass things over to Meg Harper for a discussion of some of the specific feedback that to discuss some of the specific items related to feedback we've received so far. In terms of our specific approach, so first we're looking at developing a set of draft quality standards and test methods. Our initial focus is on plug-and-play DC kits up to and including 100 watts peak. And I agree with Hans-Peter that most of the systems are likely to be considerably smaller than 100 watts peak within this plug-and-play kit space. Our plan in developing those methods is to draw from existing IEC standards and as well as other standards that are out there. There are a number of existing component-based standards that are out there to draw from. We will also draw from the existing IEC document for picosolar products where appropriate. Some of the test methods I think can be identical or very similar to those for the Pico products, although there are certainly areas where there would be differences. So we'll draw from those existing methods wherever possible. We eventually plan to submit the test methods formally through the IEC process. Probably a likely point where we might be ready for that, or the soonest we would likely be ready for that would be something on the order of June of next year. But before we do that, we are, of course, very interested to get feedback from all of you and the broader community, both on the test methods themselves as well as on the quality standards. We've already are doing that right now in terms of the first round of looking at the draft quality standards. In addition, we are interested to pilot test the methods, and so we will conduct some initial tests of products, in part in order to test out the methods and learn lessons and make adjustments where needed. We will also use that as a way of giving feedback to companies that do submit their products through that process. And that's something we'll talk about a little bit later in this webinar. And in parallel with all of this, we are working with the Lighting Africa and Lighting Asia programs, as well as Lighting MENA, to develop appropriate support and service offerings for this new sector. And so the target there again is to have those service offerings ready in parallel with finalizing the quality assurance framework, which would take place over the next 9 to 10 months. And so perhaps with a target of something on the order of June 2015 for being able to roll those things out. So I think at this point, it makes sense to pause and see if there are questions that it makes sense to answer. Keeping in mind that the next stage is the stage of the webinar where we'll talk about specific feedback that we've received so far and some of the comments in relationship to that. So we did get one question coming in from Gunnar Regner of GIZ and NDEV, which is what is the added value of the minimum quality standards for this particular market? For PicoSolar, there was nothing already in place. For solar home systems, there are standard requirements that are out there already. And it's true that there are requirements that are already in place that focus particularly on components for solar home systems, and we will draw from those existing test methods and standards quite heavily as we think about kits. But there aren't existing quality. There isn't an existing quality assurance framework out there that covers complete system-level evaluation of kits. And so in many ways, the current effort is focused on using a lot of the existing materials that are out there and adding to that a set of methods that are appropriate for evaluating at the full system level, so at the kit level. And the framework that we will develop, I think, will be a combination of those things, of the existing standards and some new methods that will focus on the system level evaluation. So there's another question coming in. This one, I can't tell who this is coming from. It's the person is just listed as viewer 61, who says, in the energy access continuum PowerPoint slide and in section 1.3.7 in the stakeholder feedback memo, it refers to the energy access spectrum from Pico product to solar home systems to mini grids. I'm compelled to point out a significant blind spot, that is the gap between solar home systems and mini grids. Before jumping from solar home systems to mini grids from AC power, one needs to recognize the great productive enterprise potential for standalone PV systems that includes water pumping for livestock, refrigeration in rural cafeterias, rural computer centers, etc. All the language seems to refer to homes unless you go to mini grids, but this ignores productive PV. No, that I think is a very good point. Certainly, there are a number of ways that solar technology and other distributed renewables can be used in that off-grid setting for productive activities. That's not something that our program is going to focus on in the near term. I think we will focus on these kit-based systems. I don't think that that's necessarily a gap in the way that people are thinking about this industry broadly. Perhaps that's just a flaw in the particular slide that we put together. But we very much are focused, I think, at the end of the spectrum where complete packages or complete kits for very small scale applications fit into the story. But that is I think a very good point in terms of applicability of this technology to a broader set of applications.
So the next question is from Joe at SolaGeo. He said, may I suggest that you consider the Hong Kong Science Park as a testing lab, as they have facilities for solar, LED lighting, and more all-in-one government-supported campus at reasonable costs. We are interested to engage with labs that are interested to operate in this space. If there are test labs out there that are interested to provide testing services, we have a policy that guides the test labs that we would be willing to engage with and accept test results from. Any lab that meet those requirements would be in a position to potentially provide testing services to the industry that we would accept. The primary requirements are that the lab needs to have ISO 17025 accreditation to provide testing services to the specific test methods that we're using, or to a set of test methods or has a set of qualifications that otherwise meet our requirements. Those are outlined on the Lighting Global website, and if a lab is interested to do that, there's an application process where they can submit their qualifications for review. And if that lab is determined to meet those requirements, we would accept test results from those labs, provided that the sample collection still happens through our framework, and that lab works very closely with us in terms of sharing the test reports with us for final review. And so if that lab or any other lab is interested to engage, we would encourage them to contact us. And our next question is from Paul Winkle. He says, hello everyone. As a last mile distributor, we at Power Mundo are curious if testing will be done once the product has been used in the field to see how they hold up.
So I'll say two things about how the testing occurs. One is that we do market check testing, which is different than what the person was asking about. In the context of market check testing, we're pulling samples from market channels to make sure that what's being sold into the market matches the quality and performance of the product that was tested originally during the qualification testing. In addition to that, we are very interested in understanding how products perform after they're used and after they're out in the field. There have been several research efforts in the past that have helped informed our thinking, and where we've taken results from those studies to understand how we should revise our quality assurance framework. And we expect to continue to do that in the future, and are always on the lookout for information about the quality and performance of those products in the field. Some of those studies have been ones where we have been involved, and in other cases, others have done the studies, but we have been able to
to review those results. And in all cases, we find that information to be useful, especially as it relates to products that we have been quality assured through our process.
And Gunnar Wegner from GIZ had a follow-up question. He said, however, how do you propose to draw the line between component-based systems and kits? Would this not reduce flexibility for solar companies who adapt their offer to client requirements, i.e. using different panel or battery or depending on the current market prices and the specific customer's load?
So I think this is one of the key questions that we have to engage with, is exactly how do we define what qualifies as a kit and as well as what qualifies as plug and play. We do have a way of evaluating families of products within the current quality assurance system, and we expect to use that same framework when looking at these larger solar home system kits. And so if a company has a family of kits that they put together from a variety of components, but sell those as complete packages, a series of complete packages, we have a way of evaluating that family, so that packages put together from that family can be ones that could be qualified under our system. And the policy that describes that family of products is also one that is available on the Lighting Global website. As always, that policy is written specifically for pico-solar products. I don't see that we necessarily would need to revise it when looking at larger kits, but that is something we'll be reviewing in this process, and we'd be interested to get feedback on that aspect as well.
Okay, and now viewer 36 says, we have developed a product which is solar home light plus a mobile charger plus a water purifier. Can you certify such a product? This product truly addresses the requirements of rural and remote areas which do not have access to drinking water and light.
And I think first want to congratulate viewer 36 and their company for development of that product. And we expect and understand that solar home system kits will have a variety of appliances that will be used with them. In the past, with the pico-solar products, our focus has been primarily on lighting and mobile phone charging, and there aren't that many other appliances that have typically been used with those systems. Once you move up to larger solar home system kits, the variety of appliances will expand greatly, and I think that is one of the challenges, but a key one for us to focus on, which is having a framework that allows us to evaluate the kits, given that they will use a variety of different appliances. We won't have specific test methods for evaluating the efficacy of the water purifier element of that type of a system, but we would have a way of evaluating whether or not the kit is able to adequately provide power to meet the energy requirements of the purifier. So obviously we're not going to go into the water testing aspect of that, but could evaluate the energy side of it.
Okay, and the next question is from Qazi Ahmad Farouk. Is there any plan about country-specific quality standards?
We are not looking to develop country-specific quality standards. We are looking to develop a framework that applies more broadly across globally across multiple markets. And I think a strong element of our program and a strong interest that we have is to have a framework that is can be harmonized and used across multiple markets. Now, of course, individual countries and organizations in various regions may be looking to develop quality standards that are country specific. In those cases, we would encourage them to consider harmonizing to this more global framework by adopting the standards and test methods that we're developing through this broader framework. And we would also encourage them to engage with us if there are country-specific concerns or things that they think are not included in our broader framework. But it's not our intention to develop country-specific requirements.
Okay. And then Joshua Pierce asked, do you see this as really becoming a customer-focused stamp of quality, or primarily a requirement for some programs? Other than a third-party verification, where do you see the biggest outward-facing function of the quality standard?
To date, with the PicoSolar products, we've primarily focused on providing verification that and delivering that information to distributors, financial industry, and other stakeholders that are a bit upstream in the supply chain. And so the listing of the spec sheets on the website and the verification letters, I think, fit that profile. We found that we can have a significant impact on quality assurance with relatively limited resources by focusing on that end of things. We do recognize that there could be a significant benefit to also reaching end consumers, and there have been some activities that have been consumer-facing, such as consumer awareness activities in particular countries. But to date, we haven't developed a consumer-facing quality seal, and we recognize that there is value in such a seal, but also that there is significant expense and some risk in developing that kind of a seal. It takes quite a bit of effort to deploy that kind of a seal effectively and to defend it from counterfeiting. I think initially in the solar home system space, the strategy that we would use would be quite similar to the one we've used with PicoSolar systems, so focusing more upstream in the supply chain and focusing on the financial industry and other stakeholders who are interested in that information about quality. We wouldn't, I think, rule out at this stage having something more consumer-facing in the future, but I don't think that that's part of our immediate strategy.
Okay. Joshua Pierce also asked, do you intend to extend testing beyond lights into other appliances?
That's not something that we have specific plans to do at this point, but I think it's something that we could discuss within the program and would also be interested to discuss with other stakeholders. I can see possibilities for doing that at some point, but that's not our immediate focus.
So we do plan to test just the basic voltage range and interoperability.
Yeah, that's correct. Meg does raise a good point, which is that in the process of evaluating kits, we of course are, especially if those kits come with appliances included within them, we do intend to evaluate the basic interoperability of those appliances. But that's different from having a separate evaluation of the appliances themselves as sort of a standalone certification or verification of individual appliances like televisions. But yes, we will evaluate the interoperability of those appliances when they're delivered with the kits, and we'll evaluate their power consumption to make sure that it meets truth in advertisement requirements.
Now, Joe at Solageo wrote, what would drive the demand for such systems as DC appliances such as LED TVs and DC refrigerators? Our TV consumes only 7.6 watt hours. However, assuming an average power consumption of 10 to 20 watts, which an end user would want to watch for 2 hours, and solar home system with lead-acid battery with 50% DOD, you would need a solar home system of 40 to 80 watt-hours, so 100 watt-hour or watt solar home system seems like a suitable target if my calculations are correct. Please do correct me if I'm wrong. I think all of those should have been watts when I read them. I apologize.
Again, I think it's not in our. We're not, I think, working to make a determination of exactly what sorts of products are likely to sell in the market. We feel that the private sector is better, as well as the consumers themselves are better determined to, or better positioned to determine that. I think initially we'll focus on this 100-watt limit for practical purposes, and this is something that we can talk through in some additional detail coming up when we talk about the specific stakeholder feedback. But for the time being, I think we'll focus on this 100-watt limit, and if we see that there's great demand for larger systems that go beyond that size, then certainly we would consider expanding the framework to match what's happening in the market.
And so Joe at Solar Geo also followed up with saying that for DC refrigerators that have to run several hours per day, if not 24/7, more than likely you would be looking at larger systems, I think, that would be out of the scope of what's being considered.
And I think, again, our initial focus is on the systems that are smaller than 100 watts. But if we're seeing significant demand for packages above that, and that's the direction the industry takes, I think we would look very carefully at that.
Okay, and then I believe the last question we have for right now is there an accelerated aging component to the testing, especially batteries, of course?
We are still in the process of developing test methods. I think that there will be some, there certainly will be some durability evaluation for batteries, and in selecting those methods, we have to strike a fairly careful balance between the cost and time of completing the testing and the value and importance of completing those tests. So we're looking very carefully at that. Batteries, I think, as all of us know, have been historically the weak link in many of these systems, and battery longevity or durability is a critical issue. It's also very challenging. Battery durability through something like cycle testing is also a very challenging and expensive area for testing in a program like this. And so on the picosolar side, we have adopted and are now using a test that can be completed in about 6 weeks that does evaluate the durability of batteries, and particularly the ability of batteries such as lead-acid batteries to withstand deep discharge. And we, I think, will adopt a test method and a requirement that is similar to that for the larger systems. But at the same time, we will. I think it will be difficult for us to adopt something like long-term cycle testing as a test method, just given the cost and the amount of time it would take to complete those tests.
Okay, thank you all for your questions for now. We're going to pause again shortly for more questions, but for the moment, we want to continue forward with the webinar and discuss some of the feedback that you've provided to date. Just to go over the stakeholder process so far, we released a set of draft quality standards for solar home system kits and requested comments between July 21st and August 11th of this year. We then compiled these comments and did a review process on the comments and provided responses along with a revised set of quality standards which is presented in a stakeholder feedback document on the Lighting Global webpage. I'll describe the process that we use to integrate these comments and to revise the quality standards in a moment. And then, of course, we are currently doing this webinar to make sure that we continue to engage with you. And following this webinar, we plan to continue to engage with all stakeholders as we finalize the test methods, the quality standards, and the program service offerings over the next year. We will regularly post updates to the Lighting Global website. You can see the link to the stakeholder engagement page for the Lighting Global website there, and I'll continue to send you emails if you have signed up for the email registration. And most importantly, I want to first thank you for your feedback. Our program would not be functioning without your input and without our stakeholders. And by providing comments and engaging in discussions on the webinar today, you help us to shape the quality assurance program to better serve the off-grid lighting market. So thank you. As far as the stakeholder feedback in this round, we received responses from 20 different and diverse stakeholder organizations, and we grouped this feedback into 48 distinct comments. Some comments overlapped, and so we combined those into a single comment. And based on your comments, we made a number of substantive changes to our program and to our the draft quality standards. I want to discuss a little bit about the process that we use to incorporate your comments. When we receive comments, we first read, summarize, and then where needed, ask clarifying questions on the comments. We then discuss any comments with our internal quality assurance team, including collaborators at the Fraunhofer Institute for Solar Energy Systems in Germany. We then discuss key issues with program managers at the World Bank and the IFC, so with the Lighting Global, Lighting Africa, Lighting Asia programs. And we also simultaneously conduct research about key issues when needed. We then take all of this input and compile responses in a feedback document, which is, as I mentioned, is posted on that stakeholder page on the Lighting Global website. And we also will present and discuss key issues in webinars like these. We, along with providing the responses, we also incorporate interim decisions in draft quality standards and test methods. In this case, we were revising the draft quality standards, so we did make a number of changes based on your comments to those quality standards. And after this process, we plan to continue to revise the quality standards and test methods over the course of the next year as we finalize this framework for testing solar home system kits. So now I'd like to walk through thinking through that process of how we incorporate comments, walk through a case of one particular comment or one particular issue, which is the system size upper limit as far as what kits we would accept for testing under this program. And just to start, our goal is to cover the majority of plug-and-play kits that are on the market while maintaining a reasonable upper bound to ensure low-cost test methods can safely assess the products. We initially proposed the following upper limit, which was if multiple solar modules are included, the combined peak power rating is between 10 and 100 watts, while the peak power rating may exceed 100 watts if only a single module is included in the kit. And with this proposal, we had intended to allow that single module to sort of provide a natural limit for the size of the kits, because we would imagine that the physical size of the module would likely provide a natural limit for the size of the kits. But we received several comments regarding this proposed upper limit. The first one was that it was confusing to have a different limit for single versus multiple modules. And we also found that, or some people wrote in and said that plug-and-play systems will be limited to smaller wattages simply due to the ampacity of most plug-and-play connectors. Another person thought, or several people thought, that 100 watts is too low of a limit, that larger systems are desirable, and a low limit will exclude products or distort the market. Some other people felt that the upper limit should not be based on a wattage, like 100 watts, but should rather be based on the current, which is what would limit the low-cost testing methods. And others felt that a wattage limit is not appropriate at all, and it should be instead the limit should be based on service offerings. We discussed this issue among our teams and discussed all of the comments that had come in. Clearly, there is no single path that that was clearly laid out by the comments. And from our team, many felt that from a technical perspective, an upper limit based on a current seemed to be the most practical. Low-cost test equipment is often restricted to measuring less than 10 amps, and so that would a limit between 8 and 10 amps for all kits would provide a clear upper limit. But many people in the communications team felt that a single upper limit based on wattage would be ideal, just for simplicity in the market, both in terms of being able to communicate the upper limit and also being able to ensure that anyone using our standards can easily understand which products are covered by our standards and which are not, or which are eligible to be covered. We further conducted internet research and reached out to kit producers and found that out of 168 plug-and-play kits that we identified, only 2% of the kits exceeded 100 watts peak. So we felt that 100 watts was a reasonable limit for the time being. And for simplicity of communications, we decided that we would stick with a straight 100 watt peak limit. But we are sensitive to the idea that there may be higher wattage systems that we might want to cover with this, and we are still considering a higher and more flexible upper bound, which could be based on a current limit. It could be based on the original proposal of where a single module could exceed 100 watts, but multiple modules would be limited to 100 watts. Or we might raise the limit slightly to 120 watts, or there may be other alternatives that we haven't yet considered. And we'd be interested to hear from you if you have any questions about the upper limit on those kits, or the upper limit for our eligibility criteria, and also if you have questions about the process that we went through to incorporate comments. And while we wait for questions on that, or wait to see if we have questions on that, there is a question that Jen Kohn shared earlier that says, how do you choose the number of units to test? Shipping cost to Germany or US of up to 16 solar home system kits with 100 watt peaks will be quite high.
And we do recognize that. So I can give just a brief outline of the approach we're using there. For evaluating the kits, at least initially, we are using a sample size of 4 for each test. In order to be able to evaluate those kits effectively and in a timely manner, it's necessary to carry out a number of the tests in parallel with each other. And some of the tests are destructive to the units, and so you wouldn't be able to use those same samples conduct tests after those tests have been completed. And so in order to be able to move through the initial set of tests that we've identified, we would need 16 samples. That includes some spare samples as well. I think following the initial round of testing, where we're going to do pilot testing for just 5 different products, we will evaluate whether or not the number of units that would need to be collected should change. So that's one of the things that we're going to be using the pilot testing for, is to determine if there are ways that we can adjust that. We do recognize that there is some significant burden associated with that, both in terms of the shipping cost as well as just the cost of providing those sample units to the laboratories for testing. And so we will stick with that requirement for this initial pilot round of testing, but it is something we will review carefully through that and may make adjustments.
We then had a comment from viewer 107 who says, I agree with less than 100 watts. For when you are in the market, most people can't afford more than 30 watts if without financial support.
And so I think that's more of a comment than a question. So I don't know that we necessarily need to provide a response in that case.
But we do appreciate the comment and appreciate getting more perspective on this issue.
Fully agreed.
Joshua Pierce writes, these are all very good points as to an upper limit. I don't see much of a difference between 100 watts and 120 watts, and the natural amperage limitations will self-select. I would go for either both 10 amps and 100 watts, maybe makes sense on technical and also the natural partition between plug and play and more complex systems.
And again, I think that's more of a comment than a question, and we certainly appreciate it, and that is in line with some of the thinking that we have been doing. And again, to reemphasize what we've said earlier, I think we'll use this pilot testing to evaluate what's practical on the technical side, and are very interested to pay close attention to what the market does, to see if there's a need to make adjustments based on what happens there as well. And so even if we are setting a limit initially of 100 watts, that doesn't mean that that's eventually what we would end up doing in the long term.
Okay. It looks like, in the interest of time, we'll move on from there. I wanted to point out that we did make a number of revisions to the standards based on your comments. A list of those substantive changes are here. We limited kits to a nominal 50-volt DC rather than allowing the 100-volt DC possibility, and limited kits to 100-watt peak rather than having the multi-level upper limit. We clarified that any appliances included with the kit must come with their requisite cables. We also refined the definition of plug and play, which we'll discuss a little bit more on in a minute. We clarified the requirement for circuit protection and whether fuses need to be included. We added that wires, cables, and connectors must be appropriately sized for the expected current and voltage. This is a safety requirement. We required batteries to be field replaceable. We clarified that the cable length is not prescribed, but does determine the level of IP assessment and durability tests for all components connected to outdoor components such as the PV module. And we expanded the description of the requirements for the user manual. Clearly, there were many more comments than that, and we strongly encourage you to read the stakeholder feedback document that's posted on the stakeholder engagement webpage of the Lighting Global website. At the end of the stakeholder feedback document is a revised version of the draft quality standards that you can review as well. And now I'd like to discuss a few key issues that came out of the stakeholder process. One is the definition of plug-and-play kits. So our slightly revised definition is that plug-and-play implies that no design expertise is required to choose appropriate system components, and no technicians or electricians are necessary to safely and successfully install and operate the system. All electrical connections can be made without the use of tools. Installation and operation instructions should be presented using language and graphics that can be understood by the typical consumer. And first off, we wanted to just mention again, we touched on this earlier in the webinar, but we got a number of questions of why are we focusing on plug-and-play kits? Why aren't we also covering component-based kits? And there are a number of reasons for this. For one, plug-and-play kits represent a new and promising approach to delivering affordable energy services in off-grid areas. Our existing QA framework, or the QA framework for these plug-and-play kits can build on our existing framework for Pico product systems. It's a much more similar design than moving into component-based systems. The approach allows for the assessment of products at the point of manufacture rather than the point of installation. And standards already exist to cover individual components. So plug-and-play kits are currently not evaluated at the system level. Arnie and Hans-Peter both touched on this earlier, and I think this is a key point, that we do plan to cover plug-and-play kits, but we want to continue to work on our definition of plug-and-play kits to make sure that it is clear and appropriate for what we are trying to test. Two key questions that we have are, one is that we would still encourage distributors to install systems for customers and train customers on the proper operation of the system. These systems can be still complicated for many, and many studies have found that having that extra level of support will increase the utility of the systems and the longevity of these systems. And so while we want to make sure that we're covering systems that could feasibly be installed without an electrician or technician, we want to make it clear that we would still encourage distributors to use technicians to install these systems. And we want to make sure our definition doesn't deter people from doing this. Another key question we have is whether screw terminals should be allowed as plug-and-play connections. They are still fairly simple connections, but are not as simple as a 12-volt jack or similar connection.
And so I think at this point we can again pause briefly to see if there are comments or questions that relate to this particular issue, or if there are other things related to the definition of plug and play that we've been talking about.
It looks like we did have one comment from Joe at SolarGeo from before, who said, it seems like it would be best to have flexibility in the maximum power or amp rating for the program. Perhaps the solar home system supplier would need to specify what they expect their solar home system to power, for example, TVs, fridges, water purifiers. And part of the testing could be to verify that the solar home system is able to power devices the supplier advises their product is expected to power.
And I think again, I think that truth in advertising is a centrally important component of the way that we've thought about these sorts of systems. And so this idea that it makes sense for the supplier to define what it is their system is intended to do is a key element of the approach, and it is in line with how we've thought about things.
there is a practical upper limit to the types of test methods you would want to use for a given size system, and there are also practical upper limits, I think, from a safety perspective for something that would be considered to be plug and play. I think that's something we would want to evaluate over time in terms of whether or not we would expand what that upper limit would be in this plug and play space. So I think reiterating the answer that we've given to date on that, which is let's start with the limit that we have and see where the market takes us. Looks like another question or two.
Looks like we have a question from Joshua Pierce. He says, field replaceable batteries present an issue for pay-as-you-go systems that attempt to protect the battery from tampering. Is this being considered?
So pay-as-you-go systems are a type of system that we are looking carefully at, and we see them as being a very promising delivery model for this space. And so we absolutely are expecting to be able to cover them within the framework. There are some aspects of pay-as-you-go systems that create some potential complications, and so that's one of the areas where we expect to have to do a fair bit of research over the coming, say, 5 or 6 months in order to determine exactly how to include pay-as-you-go systems in this and what some of the technical challenges associated with evaluating them might be. So that's one of the things that we have on our to-do list for key research topics. In terms of the field replaceable batteries and the issue of tampering, we do feel like it is pretty important for people to be able to have their batteries replaced over the life of the system. You certainly would expect the systems to last quite a bit longer than you would expect the batteries to last. And our current thinking is that field replaceable, the batteries should be field replaceable for these sorts of systems in order to ensure that consumers are able to use them not only well after the life or the period where the pay-as-you-go payments have been paid off, but also beyond the life of the battery as well. We'd be interested to engage with pay-as-you-go manufacturers or system integrators in order to think through this issue and think about how to best address it, with the principle in mind being that end users should have a reasonable way of being able to replace or have their battery replaced multiple times over the life of the system.
Okay. Gunnar Regner of GIZ said, what about roof pole mounts for panels? Do they form part of the kit?
I think that's another area where we're thinking we need to think that through, similar to the issue of screw terminals. Certainly installing a solar module, for example, on a roof or on a pole mount is a bit more complicated than, or is something that you would need at least some basic tools to be able to do, and it's something that a technician is much better positioned to do. We also know that permanently mounted modules are going to serve the system more effectively in most circumstances. So I think that we would want to allow systems that do have those sorts of mounting systems as ones that would be considered within the framework. I think we would expect the electrical connections to be plug and play, but would allow tools to be used in the case of those sorts of mounting systems.
Christopher Carlson writes, you indicate that instructions should be presented using language and graphics that can be understood by a typical consumer. Will this be a requirement or a recommendation? If required, how will you determine what is understandable, especially considering the diversity of markets and consumers?
I see this as being one of the major challenges of both delivering these sorts of systems effectively into multiple markets, as well as thinking about what is a reasonable way of presenting information so that it'll be understandable to consumers across multiple languages. And I think this is something that we're still thinking through. We have found some interesting and useful guidelines that might help us think about this. For example, from the Bangladesh IDCOL program, they're only dealing with one language type, but they do have some interesting guidelines about how that information should be presented. I think this is an area where we need to do some additional research and are interested in input. I think ultimately we'll want to take a practical approach that both addresses the importance of communication and understandability for the end user, but also the practical side of being able to operate effectively in this market from a business perspective.
Kevin at IBIS writes, so the systems would be advertised as plug and play. However, maintenance would still be essential to these systems, which probably would not be able to be done by the consumer. Do you assume the market would provide this service?
I think the short answer is yes. In some way, we would expect that either the company would provide after-sales service for these systems, and we think it's in the interest of companies to do that, or that others in the market could be in a position to provide this service. Either way, evaluation of that end of things, of the after-sales services, outside the bounds of what can be done within the type of quality assurance framework that we're setting up here. And so we recognize that those are important services. Those are important dimensions for the longevity of these sorts of systems. But from a practical perspective, it would be very difficult and actually impossible for us to be able to evaluate the effective delivery of those sorts of after-sales services globally across all of the different markets where these products could be sold, and that's just a limitation of the type of quality assurance that we're able to provide through the type of framework we're looking at and the types of resources that we're likely to have in hand.
Gunnar Wegner also writes, will a kit have one guarantee period or different guarantee periods for its different components? And this question we will cover in just a moment, so we'll come back to that. But we are, at the moment, going to stick with the proposed warranty periods of 3 years for the system and PV and 2 years for the battery. But we'll discuss that in a second. In the meantime, Ognan writes, consider staying away from the term plug and play altogether. It makes perfect sense to differentiate component-based versus packages or kits where a manufacturer or component integrator sells a branded solar home system as one big package. But whether it is plug and play or requires professional installation is a distinction without a difference. Considering that there is no such thing as a true plug-and-play solar home system, we're imagining a fantasy if we think that the average consumer will successfully do so. Systems that can be feasibly installed by a consumer is a strange way to draw the line. Picos might be plug-and-play, solar home systems are not.
And I think there are a number of fair points in that statement, and certainly I think that's something that is worth considering, and I think that's something that I don't think that we'll make that change in this initial round of pilot testing. So I think that we still will be looking at plug and play systems, but I think that there are some good points there as we've worked to try and define the boundary between plug and play, what is plug and play and what is not. I do see that there are a number of challenges there, and so I think point well taken, and one that we will actually have been discussing and will discuss internally going forward, and also one where we will value additional input and perspectives from the industry.
Joshua Pierce writes, would you consider a separate subset of requirements metrics for systems specifically designed for pay-as-you-go or solar-as-service models? Or is the goal to make the standard ubiquitous?
I think that as we examine pay-as-you-go systems, we will, I think, think carefully about whether or not there are specific issues associated with those systems that we would need to consider, or special requirements that we need to think about, or special tests that we need to think about in regard to those systems. But I think broadly, we want to follow a general set of principles that are related to truth in advertising and basic durability, and we would think that in most cases those metrics are going to apply across all system types. But again, we do understand that there are some nuances to how specific systems are or specific system types are configured, and that we need to consider those nuances.
And Quasi Ahmad Farouque writes, manufacturers usually provide warranty in hours or years. Rural people sometimes operate for more time than recommended per night. In this case, what would be the warranty?
And I think, again, we're actually about to move over to a section where we're talking about warranties, and so we'll consider that question as well as the prior one in that next section. And actually, in the interest of time, I think it's probably wise to move over to that last section.
So the next section is another key issue is the warranty. And as we said, our proposed minimum warranty terms were 3 years for the system and PV module and 2 years for the battery. On this, we received very diverse feedback. Some people said this is too long, it's not practical, and it's especially difficult for getting a 2-year warranty for batteries. Other people said this is too short. It will tarnish the image of solar home systems. And other programs like the Bangladesh IDCOL program requires a 5-year battery limit and a 20-year warranty on the solar panels. And other people said a 3-year warranty should cover the full system, including the battery, just to simplify the warranty period. And others said that the warranty terms should not be mandated, that they agreed that a warranty should be required, but that it should be up to the manufacturer. For now, because we received such diverse feedback on both sides of our proposed terms, we're going to use the originally proposed terms of 3 years for the system and the PV module and 2 years for the battery. But we would like to collect more feedback from you on the appropriate warranty terms before we finalize the quality standards. And so we would open the forum for questions or comments right now on the warranty, and are available for further comments in the future as well.
And of course, now's a good time to circle back to those 2 questions that were about that. So Gunnar Wegner had asked if there will be one guarantee period or different periods for different components. I think in a way we've answered that in that we were looking at 3 years for everything except for the battery, where we were looking at 2 years. The other comment that had come in was asking how this would be implemented. Would it be in terms of hours or years? And we've been thinking of it in terms of years, just for the sake of simplicity. And the idea there is that there is to have a requirement for a consumer-facing warranty, something that is present on the package, so that people can see the warranty, the basic warranty terms when they make the purchase. It would be from the point of retail sale, so it's a consumer-facing warranty, not a warranty based on when something enters the distribution chain. And we are, I think, certainly open to discussion about what are appropriate minimum lengths. Our focus is, of course, on having a minimum length for warranties for these products. We would want to have that minimum length be long enough to be credible, And we also see that in the context of a quality assurance program, a warranty plays, I think, one key element in the evaluation of the quality of the product, because it basically is an indication that the manufacturer is willing to stand behind the quality and durability of the system for all of the various aspects that you're not able to effectively test in a laboratory setting. But on the other hand, it's with this type of a global program, it's quite hard to use warranties as a primary element within the quality assurance framework because it's very difficult to evaluate whether or not people are effectively servicing those warranties across all of the various markets where we're operating or where they are operating, where those products are being sold. And so we have seen warranties as a potentially useful or very useful aspect of the framework, but one that has limitations in terms of how much weight it should carry in terms of its relationship to the testing elements of the program. So again, I think on that front, we are interested in feedback about the minimum lengths, and would be interested to have that discussion further. For this initial pilot round of testing, we'll keep the same framework in place, but again, the next 6 to 9 months are a period where we'll be continuing to evaluate this before finalizing anything, and are interested in continued discussion.
And Quasi also writes, 3 years warranty is okay, but it does not mean that after 3 years the system will not work. So product life should be more than the warranty period.
Yeah, we fully agree with that. That's correct. And the warranty is not meant to be an estimate of the product life, but rather the minimum period over which the manufacturer would provide warranty-based after-sales service support.
Seems quiet, so I think in the interest of time, we'll move on. There's just a couple more slides, and then we can stay open for questions for a few more minutes after that. So as we've discussed, our immediate next steps are to finalize the initial test methods. Our team is developing an initial set of test methods based largely on the methods for PICO products. And then once we have those test methods, a draft of those finalized, we will be testing 5 products. We just extended the deadline for product testing, or for applying to be considered for product testing, and it's been extended to this coming Monday, September 22nd. So if you are interested in having a solar home system kit tested, please do apply. You can, on the stakeholder website, there's a link to an update that's also on the Lighting Global webpage that gives you more information about the application process. And you can also write to me at qa@lightingglobal.org if you want more information on that. We are also going to continue to research on select topics, and we'll be doing this research over the course of the next year to incorporate some additional things into our final quality assurance framework. As we discussed, pay-as-you-go systems are high on our list for that. We're also looking into a watt-hour per day metric or some sort of performance metric that we can use to assess these products. And we're looking into a few different strategies of assessing charge controllers and PV modules and along with other topics. And so, as Arnie mentioned in the beginning, once we have our framework finalized, hopefully in around June of 2015, we will likely submit it as a revision of 6225 IEC technical specification 62257-9-6. That technical specification currently covers solar home systems, and we would submit this as a revision to that. And Simultaneously, the regional lighting programs are developing a service offering for manufacturers with products that meet the quality standards for solar home systems kits. And we expect this to be, those service offerings to be clarified to the market and available once the final framework is completed. And that, again, date is probably around June or July of 2015. And so we'd like to thank you for participating in the webinar today, and thank you for your feedback prior to this. And we are now open for questions. It looks like we have one from Quasi who says, can it be technically okay to provide warranty in watt hours or kilowatt hours per year?
I think that the way that we're thinking about this, at least for now, is in terms of just a period, so in terms of number of years, but we would be interested in hearing comments about why a different framework should be used, and so perhaps that's something that you could follow up with us by email, and we'd be interested to hear what you propose and why you think that is a reasonable way of thinking about a warranty. We don't see additional questions coming in, so if you are interested to ask a question, please do submit it. Oh, we did just got another one. Okay.
Brian W. says, just a thought, I can't think of any other product I can buy on the market in the U.S. for $200 or less that would come with a 3-year warranty. I'm not opposed to it, but I think we should be realistic about the costs that it adds.
And again, I think that's a very good point. On the flip side, I think when people think about solar home systems, they do think about lifetimes on the order of 10 to 20 years, and so I think that there is a dimension there that has to be considered. At the same time, I think we see our role in this case is ensuring that there is a warranty and a minimum length that provides credibility to the program. But we see manufacturers that it makes sense for manufacturers to use this as a way of differentiating between themselves, and so having a longer warranty period is a way that companies can differentiate themselves from others in the market. And so I do think that this is something that we're interested to continue to think about and continue to debate. And so we thank you for that we thank you for continued comments and look forward to additional discussion on this going forward.
And Joshua Pierce had a follow-up on Brian's comment as well. He said, remember, our products often represent a large percentage of a customer's annual income. And Quasi said, I don't know if he's saying cheers to that or cheers as goodbye.
And again, I think Joshua's comment is an important one. These systems do typically represent a very significant purchase for those who are buying them. So I think that we are nearing the end of the session. So we want to thank everyone for participating and thank Hans-Peter Berkhofer and GOGLA for co-hosting this event with us. You should feel rest assured that this isn't the last webinar that we'll have on this topic. We look forward to additional ones going forward, and so we hope that you'll participate through those webinars as well as through the other stakeholder processes that we'll have along the way. So thanks, everyone, and we look forward to being in touch.